We have some vocabulary behind us. With that vocabulary, we shall apply it with this sequence. Sequence is a list of numbers with a pattern in this case, and a series would be if we were adding them. Because of the commas and not the addition sign in between them, which clearly you don't see, this is a sequence, not a series. So let's move on. I need the next three terms, which means I need to find the pattern. This one's going to be a little more straightforward than most. How do we turn a 5 into an 11? We can add 6, add 6, add 6. So we're adding 6. So the next three terms would be 29, 35, 41, and it keeps going from there. We're just adding 6. So far, so good. The explicit formula. Whoa, okay, now things get fun. The explicit formula is the formula that will take us directly to the nth term. If I handed you this and I said, hey, what's the 100th term? Instead of counting first term, second term, third term, add 6, add 6, add 6, add 6 to get to the 100th term, the explicit formula will take you directly there. The word explicit in the cleanest context basically would mean direct. It is very direct. So I want to get directly to any given term. If I asked for the 100th term, what would you do? Okay, just, you don't have to write what I'm about to write. I'm going to switch colors because it's not the answer. But if I said, what's the 100th term? Instead of counting to the 100th term, you would say, all right, fine. Okay, let's start with 5. Good place to start, clearly. And then I need to add 6. Okay, I'm going to add 6. How many times are you going to add 6 to get to the 100th term? Well, I would add 6 one time to get to the second term, another time, 2 times to get to the third term. I'd add 6 1, 2, 3 times to get to the fourth term. So whatever term I'm looking for, I would have to add 6 one less time. Because if I asked for the first term, clearly I already know it, it's 5, I would not need to add 6 at all. So I would have to add 6 to get to the 100th term 99 times. That would give me the 100th term, whatever that is. Okay? Let's take that idea and actually write the answer, because the explicit formula doesn't take me to the 100th or to the 50th or to the 51st. It takes me to the nth term, whatever n is. First, second, third, fourth, a millionth. The 1,012,000th. So, same color. Let's switch colors. Here's the final answer. The explicit formula is 5 plus 6. And I would multiply that 6 by the number of times I needed to add 6. Well, if I want the 100th term, I'd do 99. If I want the 1,000th term, I'd do 999. If I want the second term, I'd multiply by 6 one time. So whatever term I want, that's n, and then minus 1. This is the explicit formula. We can go outside the boundaries of the sunlight here. We can go outside those boundaries and we could simplify this. So clearly we could have 6n and -6 and 5 would give us the -1. So either one of those is going to be valid, totally valid. Okay, find the limit as n approaches infinity of a sub n. Whoa, what is this? Okay, so let's back up for a minute. The explicit formula technically is a sub n equals this. Why is it a? Pick whatever letter you like. Don't use n because you're using it to denote, to show what term you're on. But you can pick whatever letter you want. And this was the first example we did, so we just start with A. The next one's going to be, you guessed it, B. So find the limit as n approaches infinity of a sub n. So what is the limit? Here we go. As n approaches infinity of this thing right here. That's what it is. Or this thing. Either one, same thing. 6n minus 1. Okay, so if I put infinity right there, which I technically can't do, but theoretically in my head I can. 6 times infinity, well that's huge. And then minus 1, that's just infinity. Okay, so we're approaching infinity. You could tell that from the beginning. These numbers are getting bigger. They're just approaching infinity. Okay. Let me find the paper. Yeah. All right, find the partial sum S6 of the series defined by the sequence. I was looking to see, did I ask about the recursive formula? I did not. Not in this one. So find the partial sum, S6, I want to know what the sum of the first 6 terms is. So I want to know what happens if I add the first 6 terms. That's what this number 6 means. So add the first 6 terms. Okay, good to know. So here's the hard way. 5 plus 11 plus 17 plus 23 plus 29 plus 35. Okay? And you grab a calculator and you do it. Do you want to know the answer? 120. Here's how you can do it fast. I did math in my head. Usually I get those wrong. I'm going to cry if it's not 120, or I'll just start the whole video over. So I'm going to leave some space for my work. Final answer is 120. Okay, here's how you can do it, and there's a fantastic story historically that goes with this. Historical anecdote, I was trying to say, not an antidote. I'm going to write down the first 6 terms, and this seems like a waste of time, but here's kind of the shortcut for this type of sequence. So 5 plus 11 plus 17 plus 23 plus 29 plus 35. Okay, all of these are 6 apart. So if I added 5 and 35, I'd get 40. But I would be adding 6 this way and subtracting 6 this way. So adding those is going to give me 40, and adding those is going to give me 40. So I just added 40 3 times. Okay? So I really just have 40 times 3. Well, where'd the 3 come from? Well, because I had 3 pairs of numbers. But I'm adding 6 numbers, and so when I pair them up, I have 3 pairs. So here's what just happened. That is kind of the shortcut. Is the number of terms divided by 2, and then add the first one and the last one. So here's the historical anecdote that goes with this. There was a brilliant mathematician. His name was Carl Friedrich Gauss, and he was so bright. And his elementary school teacher, we don't know if this is true, it's apocryphal, which means we're not quite sure if it's canon or not. But his math teacher in elementary school was trying to keep the class busy, and the teacher was like, add all the numbers from 1 to 100. And he was like, done, 50-50. Literally, the answer is 5,050. And so she's like, how'd you do it? Well, here's how he did it. There are 100 numbers from 100 to 100, from 1 to 100. So 1 plus 100 gives me 101. And you pair them up like that, you'd have 50 pairs. So it's 50 times 101, which gives me 50-50. Done. It's that fast. For this type of sequence, I think it's time we talked about what type of sequence this is, which is not in our list. This is an arithmetic sequence. So, arithmetic sequence. All right, let's just pause and talk about pronunciation here. That looks like arithmetic. Arithmetic is a noun, arithmetic is an adjective. So the type of sequence is arithmetic. Arithmetic sequence is when I am adding or subtracting. The most basic definition would be that. I'm adding 6 every time. Or if I was subtracting the same thing, technically I'd be adding a negative. So if I'm adding or subtracting, that would be the type of sequence. And so the general structure for this explicit formula and for the partial sum, they actually, there's some formulas that go with that. We're going to write them over in the margin in just a second. Last question, then we'll do some other stuff specific to this example with arithmetic. Does the series converge or diverge? Okay, so series, what series? Well, if I took this sequence, list of numbers, and I treated it like a series, and I said 5 plus 11 plus 17 plus 23 plus 29 plus 35 plus 41 plus 47 plus 53 plus 59, and I'm doing my thing. And I think I just messed up mathematically there. 47, 53, yeah, 59. Okay, we're good. Yeah, I was doing it right. And we keep doing that, and you never stop. What am I going to get? Well, it's never going to stop. So you're going to approach infinity. So this one is going to diverge. Okay, a couple formulas that you probably don't have to know, but while we're dealing with it, let's go ahead and address them now. So an arithmetic sequence is when I'm adding or subtracting something, and let's write it in red. We'll write it over here on the side. The explicit formula for an arithmetic sequence is this. And you actually just figured this out a minute ago. We did kind of in conversation, even though I'm the only one talking right now. A sub n, now let's do it in black to where you can see it. A sub n equals my first term. We'll call it A1. So this would be first term. Good to know. Let's pause and say more right here. Say more, say more. This would be my first term, my second term, my third term, my fourth term, my fifth term, my sixth term, my seventh term, my nth term. Whatever term I want is the first term plus that number. And that number, I'm going to call it D. D, the common difference. Okay, not D in the calculus sense like dx, dy, any of that, but the common difference. So what was I adding or subtracting every time? I was adding 6. So that was positive 6. And then n minus 1. Okay, so if they ever ask, and they probably won't, but if they ever ask for the explicit formula for an arithmetic sequence, that's what we would use. Okay, let's jump down here and deal with the partial sum. So if I want the sum of the first n terms, I can do exactly what I just did here. I could take the number of terms and divide it by 2. That's how many pairs I would have. And then I would add the first term and the last term. So my first term would be, well, A1, and my last term in the list of n terms would be the nth term. So the formulas that are good to know but are not necessarily required for an arithmetic sequence are this. For an explicit formula, if I said, give me the explicit formula, take me directly to a term, that would be it. And if I needed the sum of a certain number of terms in a list, I would do that.